Hey guys, this is Professor Janacek. I want to go over doing some calculus with our hyperbolic functions. What I have here is I've written out some of the basic derivatives and basic integrals on these. Now I do want to point out that something like this, I will say hyperbolic cosine of x. I know there are some ways of abbreviating that, but there's no need for us to use anything other than proper names in this situation. Also, I want to point out that some of the integrals are simply antiderivatives. If you've got the derivative down, so for example, this one, take the derivative of hyperbolic tangent, you get the hyperbolic secant squared. And if you can simply go the other direction. If you integrate hyperbolic secant squared of x dx, you get hyperbolic tangent of x. So once you remember the derivative rules that I have written here, you should easily be able to remember at least some of the integration rules. Let's go ahead and try some examples. Let's see here. For the first example, I want to take the second derivative of the hyperbolic secant of 3x. Well, it's the second derivative, which means we will take the derivative of the derivative. All right, so taking the derivative of this inside bit, let me just write that down, that second derivative out there so I don't forget about it. Now, taking the derivative of this inside bit in here, all right, it's hyperbolic secant, so we'll use this property. However, it's got a 3x in there, so I need to remember to use the chain rule on that. Which means, so we've got negative hyperbolic secant of 3x, remember my argument is 3x, times the tangent, hyperbolic tangent of 3x. But chain rule says I need to multiply by the derivative of the inside function. In this case, 3x is my inside function. Its derivative is 3. So we end up with negative 3, I'll just move the 3 to the coefficient, negative 3 hyperbolic secant of 3x times the hyperbolic tangent of 3x. Now, in order to take the derivative of this bit, notice I have a secant and a tangent. I have two functions being multiplied together. I am going to have to use the product rule. Now, I'll go ahead and just write this negative 3 as my coefficient and leave that alone, not worry about that. So that's first. Now, product rule. I'm going to use a version of it which kind of follows the direction of the quotient rule. I like to kind of have those down in a similar fashion. There are many ways of remembering the product rule. Remember, multiplication and addition are both commutative, so there are a handful of ways that you can write this. So I'm going to go ahead and use the version where we take, I'll call this my first function, and this my second function. And we'll take the second times the derivative of the first. Now the derivative of that first hyperbolic secant of 3x, we did that above, so I know that's going to be negative 3 hyperbolic secant of 3x hyperbolic tangent of 3x plus. Now we're going to write, again, I'm not worried about that negative 3 in the front. I've already got that taken care of. Now it's going to be the first, which is hyperbolic secant of 3x times the derivative of the second. Notice our second is hyperbolic tangent of 3x. I'm going to use the hyperbolic tangent rule up at the top. That's just hyperbolic secant squared. But again, chain rule will end up with an extra 3 in the front. Let me go ahead and just write it in order. It's going to be the hyperbolic secant squared, 3x, and then times another 3. Let's clean all this up just a wee bit, just one little bit at a time. I've still got the negative 3 in the front. Here I've got negative 3 hyperbolic secant of 3x, and then this tangent and this tangent. If I multiply those together, it's hyperbolic tangent squared. All right, on this one, I'll put this that 3 out in the front. And then we have the hyperbolic secant is now cubed, because I have a squared here and then a power of 1 there. Okay. I can clean this up a wee bit more. Let me go ahead and factor out, since I see that I've got a negative here in the front, so let me go ahead and factor out a negative. And along with that, I'll factor out, I've got a 3 here and a 3 there. So let me factor out a -3 to go along with the -3 that's already there, which gives me a +9. The other thing I noticed that's common here is I have a hyperbolic secant and hyperbolic secant. Let me go ahead and factor out one of those, just one. So that's hyperbolic secant of 3x. What's left? Let's see, we end up with a hyperbolic tangent squared of 3x minus, notice because I factored out a negative, minus hyperbolic secant squared of 3x. Whew, there we go. All right, well that one was kind of exciting. Let's see about the second one. Let's integrate from 0 to the natural log of 3 of hyperbolic sine cubed of x times hyperbolic cosine of x dx. Well, I think a u substitution is in order here. If we let u equal to the hyperbolic sine of x, then du is hyperbolic cosine of x dx, which we have. There is in the back. Oh, lovely. So I can really just write this as the hyperbolic sine of x cubed times hyperbolic cosine of x dx. And so there we have, there's u and there's du. So we're going to be integrating u cubed du. Oh, that's an easy one. How lovely is that? That's 1/4 u to the 4th. Over here in my definite integral, though, we end up with u is, again, the hyperbolic sine, so I end up with 1/4 hyperbolic sine of x to the 4th power, evaluated from 0 to the natural log of 3. All right, well, let's go ahead and write this down. That would be 1/4 hyperbolic sine of the natural log of 3. That bit is raised to the 4th power minus 1/4 hyperbolic sine of 0. Again, that bit's raised to the 4th power. Okay, well, let's think about evaluating a hyperbolic sine. We have to remember what the definition of hyperbolic sine is. Recall that hyperbolic sine of x is e to the x minus e to the negative x over 2. And hyperbolic cosine, just as a reminder, is e to the x plus e to the negative x over 2. So this gives us, we've got 1/4 e to the natural log of 3 minus e to the negative natural log of 3 over 2. All that is raised to the 4th power minus 1/4 e to the 0 minus e to the 0 over 2. And again, that bit is raised to the 4th power as well. Whew, my, let's see. Well, e to the natural log of 3, oh, and make sure that's clear, that is just an argument of 3. E to the natural log of 3, that is just 3, right? But what about, actually, while we're looking at, what about this one, e to the negative natural log of 3? How do we do that? Let's think about this one. E to the negative natural log of 3 using properties of natural logs, that's e to the natural log of 3 to the negative 1. But 3 to the negative 1 is 1/3. So we have e to the natural log of 1/3. E to the x and natural log of x are inverse functions, so we just simply get 1/3 on that. Oh my, isn't this fun? So we have 1/4, 3 minus 1/3 over 2 raised to the 4th, minus 1/4 of e to the 0 is 1. E to the 0 again is 1. All right, that second bit's going to be pretty easy. All right, I'm going to let you guys take a moment and give that a shot, see what you come up with. It should all simplify down to 64 over 81. Let me just make sure I've got that written correctly. 8. Yeah, I'm happy with that. 64 over 81, that works just fine. Okay, so let's move on to the example 3. We're going to integrate x times the hyperbolic cotangent of x squared dx. Well, again, let's try a u substitution here. If we let u equal to x squared, then du is 2x dx. Well, that's not so bad. So if I rewrite this as what am I doing? Hyperbolic cotangent of x squared. Now I'm going to move this x, I'm going to move that x to the back. But I notice that I will need a 2 in there. 2x dx is what I really want back there, so let's put that in there. If I put a 2 in here, that means I'm going to want to have to balance that out with a 1/2 here in front. Oh, I could do better than that. So now, looks like here is u, and back here in the back that all is du. Now in this case we're going to integrate hyperbolic cotangent of u du, which means we're going to simply use, let's see, integrating hyperbolic cotangent is this one right here. Well, that's not so bad. We still have the 1/2 in front, and it's the natural log of the absolute value, hyperbolic sine of, in this case it would be u, but u is x squared, so I'll write it as x squared, and plus c. Well, there you go. That wasn't so bad. Enjoy!